So a certain amount of zirconium is the element is a certain size, okay, the one atom of it. Every once in a while, if there's uranium in the vicinity, uranium will substitute in for zirconium in that crystal lattice. And we're talking, you've got 5 billion atoms in this massive rock, and maybe one in every several thousand is replaced by uranium. Okay. Uranium's happy there because it fits size and charge-wise. Okay. But lead is, so if you're on your periodic table, zirconium is here. Okay, and size goes up as you go down the periodic table, and it also goes up as you go to the left. Okay, so zirconium is here. Uranium is actually over a little bit and down. Okay, but lead is all the way over here. So it is a big, fat, ugly atom. And it does not fit in the nice, cozy space that zirconium likes to live in. So uranium, the uranium atoms that are substituted in for zirconium in zirconium silicate, eventually they decay radioactively, like we talked about yesterday, and they become lead, ultimately, in the tail end. Okay, so what you end up with is a rock that is mostly zirconium silicate, with a little bit of uranium left, and lead deposits on the edges, because the lead just leaves the crystal lattice. It doesn't like it there, it doesn't want to be there, so it leaves. And it goes and it hangs out on the edges of things. You can measure the amount of uranium, the amount of zirconium, and the amount of lead in this rock mass and determine, okay, this is how much parent I have, this is how much daughter I have, I know how much parent I should have had, therefore this is how much has decayed, so this thing is so old. Does that make sense?
Yes.
Awesome. So now we're moving on to life. Ready? Okay, based on the fossil record and radiometric dating, life on Earth is estimated to be about 3.5 to 4 billion years old. Okay. Now, there are many assumptions folded into this estimate. Here is a picture of the geologic timescale. And so you can see that we are right here. Okay.
Wait, with the really thin line?
Yeah, we're here near the zero.
Oh, okay.
Okay, so this is right now. This is us. And then this is years going backwards. Okay? And so
Pennsylvania.
this time period right here is the Precambrian time. Okay, and this says 4.55 billion years ago. Okay, based on, and again, that is based on radiometric dating of rocks. Okay, the oldest rocks we've ever found are 4.55 billion years old. Okay, so working your way, this whole era in here is called the Precambrian time. Time before the Cambrian period. And the Cambrian period starts with the Paleozoic, or it's Paleozoic and then Mesozoic and then Cenozoic. And then this is the Cambrian period. Really, what's interesting is right here, so this is Cambrian. This area right here is the area where life existed. And you can see that in the scope of things, that's not really a whole lot. But right here at the Cambrian explosion, you right there? Right there at the Cambrian explosion, that is when all of the major phyla of life appear in the fossil record. And so before that, there are indications that there was some life, but then, especially in here, but then with the Cambrian explosion, which happened during the Cambrian period, 570 million years ago.
Wait, what exactly is the Cambrian explosion?
it is an explosion of life. It's where
Oh, so it's like
life.
the Big Bang?
No, it's like you go from having very little life to having every major phylum of
like
life.
in the past 20 years, how our technology has grown so much.
It's like that.
Okay, so it's
It's
kind of
like-
like a boom.
Yes, it's like a sudden expanse of life. So you go from having very little life on Earth.
So not like a literal explosion.
Right,
Okay.
right. It's a metaphor.